This is Geometry Lesson 2.3, Converses. So the big idea says every conditional statement, which is what we talked about in Lesson 2.2, has a converse found by switching its antecedent and consequent. And the converse may or may not be true even if the conditional is true. So let's jump right in. When we look at what a converse is, the converse of if P then Q is if Q then P. We are switching P and Q, which represent the antecedent and the consequence. We are going to switch the antecedent, which is our if statement, and consequent, which is our then statement. So we're just going to switch them, and that is called the converse. According to the big idea, it may be true or it may not be true, even if the original conditional statement was true. So let's take a look at a couple. Number one, consider this statement. If you live in Michigan, then you live in the United States. Is this statement true? Yes. If you live in Michigan, you live in the United States. That's true. Write the converse of this statement. So we're going to switch the antecedent, which is you live in Michigan, and the consequent, which is you live in the United States. So it now is going to say, if you live in the United States, then you live in Michigan. If you live in the United States, then you live in Michigan. Is the converse true? No. In this case, it is not. You can live in the United States and not live in Michigan, obviously. So in this first case, the original statement was true. When we took the converse, it was not true. So I wonder, does that always happen? Statement number two. If x equals 10, then 3x equals 30. Is this statement true? If x equals 10, then 3x equals 30. Well, if x is 10, 3 times 10 is 30. Yes, that's true. Write the converse. So we're going to switch these. If 3x equals 30, then x equals 10. Is that true? If 3x equals 30, then x equals 10. Well, if I was going to solve this, I would divide both sides by 3, which would cancel this out, and I'd be left with x equals 10. So is the converse true? Yes. So as you can see, taking the converse does not necessarily always change whether it's true or not. It can be true and become false. It can be true and stay true. And number 3, let's relate this now to our Venn diagrams. Let S equal a figure is a square, and let R equal a figure is a rectangle. So squares and rectangles are related. Both of them are four-sided polygons. Both of them have 4 90-degree angles. That's what makes it a rectangle. And a square, more specifically, has 4 equal sides, where a rectangle does not have to have 4 equal sides. Okay, but the definition of a rectangle is a 4-sided polygon with 4 90-degree angles. So a square fits that. A square has 4 sides and 4 90-degree angles. So a square is a rectangle, and that's what the Venn diagram here shows. So the Venn diagram shows the relationship between the figures that makes S true and the figures that make R true. So this circle represents all the different figures you could draw, all different shapes and sizes that make it a square, and these are all the different figures you could draw that fit into the definition of a rectangle. So based on this Venn diagram, you can see every square that you could come up with fits inside the mold of a rectangle. So every square is a rectangle. But out here in this space, there are rectangles that do not fit inside the squares circle part of the Venn diagram. And we know that we can draw a rectangle that's not a square, but you cannot draw a square that isn't a rectangle. Every square is a rectangle. Four-sided polygon, 490-degree angles. So part A, we're going to write if S, then R in words. So S is the figure as a square, R, the figure as a rectangle. So if S, then R. So if a figure is a square, then R, the figure is a rectangle. According to the Venn diagram, is this true? If you have something inside the squares portion here, is it inside the rectangle portion? Yes. If a figure is a square, it is a rectangle. That's true. Now let's write the converse in words. So switching S and R. If a figure is a rectangle, then the figure is a square. So if I pick any rectangle inside this circle, it is going to be a square. That is not true. So is this true according to the Venn diagram? No. Just because something is a rectangle doesn't mean it is a square. So in this lesson and in your work now, you're going to examine how do I rewrite a conditional statement as its converse, and then you're going to examine if it is still true or if it is now false.